Actually, నాదేమో డబుల్ క్లిక్ చేసి ఓపెన్ అయ్యేది. డబుల్ క్లిక్ చేసి నా ఓపెన్ అయ్యేది. Good morning, students.
Good morning, sir.
Right. So, the last class we discussed about the organic parts. Okay, so friends, we have discussed that organic chemistry. In that organic chemistry, what is the main important of the history of the organic chemistry? Why the organic chemistry is important to us? So in that way, I given some examples. The first organic compound is synthesized by the polar in the laboratory, that is called as urea. And mostly the question is in that particular urea, what is the structure of urea is asking. So remember the NH2CO, NH2 is the formula of the urea. That is the first organic compounds which is synthesized by the polar with the two inorganic salts. Okay, potassium cyanate and ammonium sulfate. For that, we are getting of the urea is obtained. That is the first organic compound. So that your definition is modified. The compound, that means the study of the carbon compounds is called as organic chemistry. In that way, we are utilizing, that means in the 1944, Henel and Cole, those are synthesized the ethyl alcohol and acetic acid. They named the compound C2H5OH is the ethyl alcohol, acetic acid is CH3COOH is the acetic acid, like methanol. So many other compounds are synthesized. So observing of these organic compounds, they feel as the compulsory carbon element is present. So that now we are studying of the study of the carbon compound is called as organic compounds. So that's why you are using of that one. This organic compound classification for your examination purpose. What is the classification of organic compound? And also I told that yesterday last class, that is an important of the classification. By you are understanding the classification means total organic chemistry is present in that particular classification only. Please try to understand the classification. What is the classification of organic compounds? So the classification of organic compounds. How the organic compounds are classified? The classified into mainly important of the organic compounds are classified into two categories. First category is called as open chain compounds. Open chain compound. The first classification is open chain compound, and it is the closed chain compounds. By reading out these particular words, we know that one. Open chain compounds means what? The arrangement of the carbon atoms are in a straight chain or a branched chain, like this. The carbon atoms are arranged. It is a straight chain, whatever it may be. Okay, or it may be a branched chain, like this. I'm using of. Okay, this is a branched one. This is called as open chain compounds. Open chain compounds means nothing but the carbon atoms are arranged in the straight chain form or a branched chain form is called as a open chain compounds. Now coming to the closed chain compounds means is a closed compound means it is nothing but we are observing of the cyclic compound. It is a closed chain means it is called as a cyclic compounds. That means they are forming the closed form. That means it is arranged like this. I am writing up the closed form. There is no open. They are closing organ. Okay. So you know that already familiar with your benzene ring structure. This is the benzene ring. It is a closed chain. So it is nothing but the cyclic compounds called as a closed chain compounds. The carbon atoms are in closed form. Those are called as a closed. Now we are discussing about the one by one. So open chain compounds and also as well as the cyclic or cyclic compounds, which are important to our first year set. Coming to the open chain compounds. Open chain compounds, these are further divided into saturated hydrocarbons, saturated compounds, and unsaturated compounds. Saturated compound, unsaturated compounds. So what is saturated? I already told that the carbon atom is a tetravalence in nature. This carbon atom, this tetravalence of the carbon atom will be satisfied with the all single covalent bond. The carbon is satisfied with the all single covalent compounds or its bonds are called as saturated hydrocarbons or saturated compounds. Means sir, why? If you see the methane molecule, the methane is a CH4 is a methane. The formula of methane is CH4. This CH4 methane compound, you have seen that this carbon atom is satisfied with the all single covalent bond with the 4 hydrogen atoms. This is the methane structure. We are writing up this one. This methane structure is explaining the saturated hydrocarbon. Saturated carbon means the carbon atom is satisfied with the 4 covalent bonds. 4 covalent bonds is satisfied. That's why it's called as a saturated hydrocarbon. So in this saturated hydrocarbons or saturated compounds, the example of saturated hydrocarbons are the compound is alkanes. The general form is called as alkanes. So generally, the saturated compounds are called as alkanes. What do you mean by the alkanes? Al plus ane. Al is the common word, this is a root word. Ane is the suffix. This is the ane is nothing but a single bond is present between the carbon and carbon. This is called as the alkane. Now in the second chapter, we will study about the alkanes only. This alkane means the general formula of alkanes. General formula, that is GF with general formula. The general formula of alkane is CnH2n plus 2. It is important for your examination point of view. What is the general formula of alkane? CnH2n plus 2. Means if n is equal to 1, you are writing of n is equal to 1. Writing of what? C 1 means oh, what right? And n is equal to 1 means 2 plus 2. It is nothing but CH4. If you are writing of 2 means C2H6. 3 means C3H8. Okay. So friends, like this, you are writing of the compounds C4H10. We are writing. This is a comes under the saturated compounds that is called as the alkanes. Now, if any compound is having of that particular organic compound consisting of only one carbon atom, that is called as a myth. One carbon is called as a myth. So it is myth. Myth is the what you are having of this alk. Alk is the root word. Here myth is the root word. If the compound is consisting of only one carbon, any of its primary suffix is ane is there. So it is the methane. So why you are writing the methane is one carbon is present in this particular saturated compound, so that you are using of that one. This particularly you are using myth plus ane. Again the Greek word. If two carbon is there, it is called as a eth. Ethane. If 3 carbon atoms are there, it is called as a propane. If the 4 carbon is there, it is called as a butane. If the 5 carbon atoms are there, pentane. If the 6, hexane, heptane, octane, nonane, decane. Like that, you are classified the if the organic compound consisting of number of carbon atoms. So the Greek words are derived as one carbon is called as a meth, 2 is called as a eth, prof, but, pent, ex, hept, oct, non, dec. Like that. Suppose if more number of ecoicenes, those are called as up to dec is a perfectly is given. Next after is a again the making of the other decane only. From that we are getting of this one. So this you have to remember at least the carbon atoms consisting of the these are the numbers are present. See the friends here, your alkanes having the general formula. I am writing the so many number of carbon compounds which are present in the saturated hydrocarbon. There is the alkene series. Okay. See the first compound in the alkane series. The methane is the first compound. Why? Because there is only one carbon atom is there. The next family is called as an ethane. If you have 2 successive compounds are there, in these 2 successive compounds, the difference is how much is there? The difference one carbon atom is there, 2 hydrogen atoms are there. One carbon atom, 2 hydrogen atoms are different in this compounds. Any series, the 2 successive compounds, the difference is 1 carbon atom and 2 hydrogen atoms are called. It is the homologous series. This series is called as homologous series. So friends, it is also very important in your examination point of view. What do you mean by the homologous series? Means in any series, the 2 successive compounds are differ by 1 carbon atom and 2 hydrogen atoms is called as a homologous series. So alkanes are homologous only. You see, any one ethane, propane, the difference is 1 carbon atom, 2 hydrogen atom, or propane, butane, 1 carbon atom, 2 hydrogen atom. Like that, you can see the any one. This is about the alkane saturated hydrocarbons. Okay. So next we'll go to the unsaturated hydrocarbon. Unsaturated means the carbon arrangement, the carbon bonds are arrangement in a unsaturated hydrocarbon. The carbon between the carbon atoms arranged as a like this, either double bond or a triple bond is present between that one. See friends, again I am using of this particular structures. The carbon atom is satisfied with all four covalent bonds. 1, 2, 3, 4. Four bonds are present on the carbon atom. Here also 1, 2, 3, 4. Four covalent bonds are present. See this in the ion also you are having a triple bond is 1, 2, 3, 4. Is on this each carbon atom is four covalent bonds are there. But in this it is a double bond is there. It is in the triple bond is. If double bond is called as that is a alkene. Ene is called as a double bond. If triple bond is called as alkyne. Ine is called as a triple bond. Okay. These are the important compounds which are using of the unsaturated hydrocarbon means alkene, alkyne. So if you are writing of this one means in this first member of the alkene series, minimum number of carbons are 2 only. But in the alkane series, the minimum number of carbon is 1 only. You can start with the 1. But here you have to start the 2 carbon atoms. So it is nothing but you are writing of CH2 double bond CH2. This is nothing but ethene. The name is eth. Why? Because it is eth. It is already Greek word. It says that if number of carbon atom 2 carbon is there as eth. It is a double bond is there. It is then ethene. Okay, so I'm writing it is a structure. Just I write the formula. It is nothing but C2H4 is called as a ethene. C3H6 is called as a propene. C4H8 is called as a butene. Like that, we can write any number of carbon atoms. Okay, friends. Here the alkene is a double bond is present between the carbon and carbon. So you are writing this particular alkene general formula is CnH2n. The general formula of alkene. This is important. And here the general formula of alkynes is CnH2n minus 2. That is the alkynes. So I am writing out this particularly. In the alkenes, the general formula is CnH2n means you put out the N is equal to 2 means you are getting off C2H4. N is equal 3 means C3H6. N is equal 4 means C4H8. These are ethene, propene, butene. Like that you are pronouncing this one. See this in this particular alkene series also. Any two successive members, this ethene and propene. Ethene and propene. The difference is again here also one carbon atom and 2 hydrogen atoms. One carbon and 2 hydrogen atom is differ by the any two successive compounds is called as again homologous series. That means alkenes also comes under homologous series only. So it is very important. What do you mean by the homologous means any two successive numbers in a series is differ by the one carbon atom and 2 hydrogen atoms is called as a homologous series. So alkenes also homologous. The general formula important here. Alkane general formula is CnH2n plus 2. Alkene general formula is CnH2n and alkyne general formula is CnH2 minus 2. Simply what happened in this particular first formula CnH2n plus 2. Just remove the 2 number. You are removing the 2. You are getting of CnH2n. It is belongs to the alkenes. Again remove the 2. That means CnH2 minus 2. It is called as the alkyne. So you have to remember like that in the examination that easily. CnH2n plus 2 if you remember one formula that is belongs to the alkanes. The remaining you have to remove the 2 number. That means it is the alkane. Again remove the 2 more. It is nothing but alkyne. This is about the open chain compounds. So in your book it is not given, just given what do you mean by the open chain compound? Means the carbon atoms are arranged in the stage form or a branched form is called as open chain compounds. But in this open chain compounds, again you are further divided to saturated compounds, unsaturated compounds. Saturated means the carbon atom is satisfied with the only single bond. Only with the single bond is called as saturated hydrocarbons. Unsaturated means the carbon of bond in between the carbon and carbon, there is a double bond is present. That is called as unsaturated. If the carbon is between the carbon, triple bond is called as very unsaturated hydrocarbon, very unsaturated compound. This comes under this one. So saturated is the mainly important is the example is alkanes. Unsaturated comes under alkenes and alkynes. And remember the formulas. And also I written only few number of compounds. That means if the organic compound any number, the carbon atoms are only one is called as a meth. If it is a 2 eth, it is a 3 fro. If it is a 4 means but, pent, ex, ept, opt, none, dec. You have to remember up to dec. Okay, so this is about the open chain compounds. Now we are coming of cyclic compounds. The cyclic compounds again further divided into homocyclic compounds and heterocyclic compounds. Now, yes, this cyclic compounds again might further divided into homocyclic compounds and heterocyclic compounds. What is the meaning of this homocyclic? Means only carbon and hydrogen atoms are present. Only carbon and hydrogen atoms are present. Those compounds are called as homocyclic. Hetero means apart from the carbon and hydrogen, one more other elements like nitrogen, oxygen or sulfur. These are the three elements, sometimes halogens also. Nitrogen or oxygen or sulfur or halogens. Those are present apart from the carbon and hydrogen. Those are called as heterocyclic compounds. So friends, homocyclic means we are adding up the little bit idea with the homocyclic compound. Those are arranged in this one. That particularly only with carbon and hydrogen atoms means these are the carbon and hydrogen atoms only present. I'm not. See, this is the bonds. If you see that one, how many bonds are present on each carbon atom? 1, 2, 3, 4. 1, 2, 3, 4. Every carbon is satisfied with the 4 bonds. 4 covalent bonds is there. It is in the closed form. That's why it is the cyclic compound. It is why it is homocyclic means no other element except hydrogen and carbon atoms are there. These are the hydrogen atoms and carbon atoms are there. That's why it is called as homocyclic compound. Here, heterocyclic compound means hetero means apart from the carbon and hydrogen, nitrogen or oxygen or sulfur or halogen atoms are present in that particularly. Suppose if you say taking of that one carbon, these are the compound, one compound I am writing of the example of that one. It is a furan. It is a furan. It is a heterocyclic compound. It is also learned in the second chapter. That is a heterocyclic. Sorry, we are writing of the second sem in that only. So furan is the heterocyclic compound. We are using of this one. This but you see the carbon atom is nothing but we are having up 1, 2, 3, 4 bonds are there. Here also 4 bonds are there. Every atom, but is an extra apart from the carbon and hydrogen, oxygen is present. Like that, furan, ferrol, thiophene. Ferrol, nitrogen is present. In the thiophene, sulfur is present. Those are called as a heterocyclic compounds. Hetero means extra other atom is present apart from the carbon and hydrogen. Okay, this is about not in our first step, but this is a homocyclic compounds. We are adding up the first step. These homocyclic compounds are further divided into. I don't want to this one. These homocyclic compounds further divided into alicyclic compounds, and aromatic compounds. Alicyclic as well as the aromatic compounds. So alicyclic means simply the alicyclic compounds are nothing but those are present carbon and hydrogen and a single bond is present. It is a saturated compounds. Alicyclic compounds are nothing but saturated. Saturated means only single bond is present. It is aromatic compound means it is unsaturated. That means there is a chance of double or triple bonds are present. See, further I am dividing the highly cyclic compound. Those are called as a cyclic compounds. This is present in that alicyclic compounds. Cycloalkanes. The best examples are cycloalkanes. That also present in our second chapter. After the saturated hydrogen alkanes and cycloalkanes, means we are having of this particular carbon atoms are arranged in the cyclic form. Only single bond is present. Okay, this is a single bond is present between the carbon and carbon. Or you can see this is a single bond is present. See friends here, how I am writing these are structures of the compounds. Now this compound, cyclic compound is there. There is a 3 carbon atoms are there. 3 carbon means what is the Greek word? Pro. It is a saturated. A propane is there. So it is a propane according to our concept. But this particular carbon atoms are arranged in the cyclic form. So it is called as cyclopropane. Are you getting this one? Why am I prepare? So difference between the propane and cyclopropane. Propane is the same. We are adding up the 3 carbon atoms are there. Single saturated bond is there. But it is in the cyclic form. It is called as a cyclopropane. So what about this one? How many number of carbon atoms are there? 4 carbon atoms are there. So means but. It is the saturated. Single bonds are there. N is there. But these are arranged in the cyclic form. So that it is called as a cyclobutane. Cyclobutane, cyclopentane, cyclohexane, cycloalkane, cyclooctane, like that. That means the carbon atoms are arranged in the cyclic form. Those are insaturated. Saturated means what? Only single bond. That is called as a alicyclic compound. So in that cyclic compound, that is comes under homocyclic. Homo means similar atoms, only carbon hydrogen. Those concerned on alicyclic means only saturated one. Coming to the aromatic hydrocarbon. Aromatic hydrocarbon best example is benzene. Why I am using of this benzene means this aromatic hydrocarbon. Just I am writing the cyclic structure. See friends, this is nothing but carbon atom. Here carbon, here carbon, here carbon atom, carbon atom, carbon atom, carbon atom. There is a presence of the carbon atom. The carbon atom present means the formula of benzene is C6H6. The formula of benzene is C6H6. Here single bond is there, double bond is there. Single bond, double bond, single bond, double bond. It is called as aromatic hydrocarbon. Aromatic cyclic compound. The cyclic compound means the carbon and hydrogen atoms are arranged in the cyclic form, but there is an alternative single and double bond is present. Those are called as aromatic hydrocarbon. So aromatic hydrocarbon, the examples are benzene, naphthalene. Naphthalene, you are using the naphthalene balls in your household purpose. Anthracene, penanthracene. These are all comes under the aromatic hydrocarbons. These aromatic hydrocarbons are nothing but there is a presence of alternative single and double bonds are present. This like benzene structure we are writing up. This is about the aromatic hydrocarbon. So this is about the main important classification of our organic compounds. The organic compound broadly classified into open chain compounds, cyclic compounds. Open chain compounds further classified into saturated hydrocarbons, unsaturated hydrocarbons. Saturated comes under the alkanes. Unsaturated means there is a double and triple. Double bond is called as alkenes. Triple bond is called as alkynes. So alkane general formula is CnH2n plus 2. Those are nothing but methane, ethane, propane, butane. Alkane means CnH2n formula, general formula. So that is called as ethene, propene, butane, like that. No single carbon. Why? Because in between double bond is present between the carbon and carbon. Similar manner in alkynes, that is a triple bond is present. The first compound in the alkyne series is ethine. Ethine is also commonly known as acetylene. The common words also somewhere you are important. Why? Because acetic acid you are calling. Acetic acid, see what is the formula of acetic acid? CH3COOH. CH3COOH means organic compound consisting of how many number of carbon atoms are there? 2 carbon is there. One is in the CH3, another in the COOH. 2 carbon means according to our nature. What is the designation of the Greek word? Eth. 2 means it. It is the name of the acetic acid. Name is ethanoic acid. Ethanoic acid is the IUPAC name. Acetic acid is a general name. Please remember, don't confuse. Okay, friends. Ethyl alcohol. C2H5OH, the formula of ethyl alcohol. According to the IUPAC nomenclature, there is a 2 carbon atoms are there. One alcohol functional group is there. That is all. That means it is called as ethanol. It is a IUPAC name. Generally, you are pronouncing ethyl alcohol. Just ethyl means what? From ethane. Ethane, the formula is C2H6. Ethane is the formula. You are removing of one hydrogen. It is called as oil. Any compound is removed by the one hydrogen is called as oil. Ane means you are getting of oil. Ethyl. Ethane comes as ethyl. What is the functional group is there? OH. It is alcohol. Ethyl alcohol. It is a commonly using of the ethyl alcohol. But the IUPAC name is ethanol. It is a Greek word. All is there. There is a common word is that is a functional group. I will explain the functional group. What are the functional group can present in this? Particularly, you have to remember this is the classification of organic compounds. Sometimes in the examination, the classification also asking for the 10 marks question. So this is, please remember the 10 mark question of the alkanes. That is a just you write the few compounds for any one classification. Write the one example. That's enough. No need to write all the examples. One example for each classification. We are writing of that one. Okay. Next, we will go to the classification of the organic compound based on the functional group. Okay. So based on functional group, very important, ma. From if you are identify the functional group, then only you are pronouncing the name. Suppose I am using of the single bond is there. It is called as a ane. Saturated hydrocarbons, that means ane is there. So alkane. If the double bond is there, it is called as a ene. If triple bond is there, it is called as a ine. Whatever the alkyne. The root word is the alk. Common is the root word for anyone. But your primary suffix is ane, ene, ine is there. Suppose the organic compound is having of the OH is the functional group is there. The OH is called as alcohol. So that is the alcohol. Suppose a carbon compound is having of a CHO. CHO is there. That is called as aldehyde. That's you have to classify the organic compound based on the functional groups. Okay. Classification of organic compounds based on functional groups. I list out some of the organic compounds which are present in the based on the classification. We are writing of the so many compounds, but I am using of this compound name. That is a functional group. What is the functional group? Is there? Okay. The functional group. What you are called as that particular compound is what the class of the compound. That means name of the functional. Name of the functional group, writing of example. You can write the example. See, this is enough for your examination point of view. It is also asking. Suppose a single bond is there. It is functional group name is A. Example is this is ethane. It is simple. We are writing. Suppose the functional group is ene. This is the functional group is ene. It is the ethene. If the functional group is triple bond is there, it is ine. So I am using of ethyne. See friends, are you observing or not? I am taking only 2 carbon atoms for any Here N is there, here E is there, here I is there. Simply I am writing of that organic compounds. You can take any number of examples. If the single bond is there between the carbon and carbon, is called as A. If the double bond is there between the carbon and carbon, it is called as E. If triple bond is there, it is called as I. Okay. So remaining I will go to the next one. These are the common classification of the organic compound and the functional group. Next, we will go to the common compounds that we are present in this particular compounds. Next, I am writing of the compounds which are present in this particularly. They are having of the 3 bonds. One is there. Don't confuse.
Mute lo vettandi cell.
This is the carbon is 4 bonds are present, which is present OH. This is the functional group. So functional group is OH. This is called as alcohol. If the functional group is OH, it is called as alcohol. Example, I am writing of the example. CH3OH is called as a methanol or methyl alcohol. Methyl alcohol. Okay. Suppose a functional group HO is there. The functional group is CHO. It is called as aldehyde. I am writing the simple same. I am taking out CH3 CHO. If the CH means acetaldehyde, this is called as acetaldehyde. The name is acetaldehyde. If this is COOH, it is called as carboxylic acid. It is called as a carboxylic acid. So I am writing off CH3COOH. I am taking the common CH3. OH is there, methyl alcohol. Aldehyde is there, acetaldehyde. It is acid is there. This is called as acetic acid. Okay, friends. If you are observing, I will be using of same compound names. If suppose using of C2H5, ethyl alcohol. Here, if you are using of that one, that means C2H5, ethyl. That is already ethyl is there. Aldehyde group is there. Means propanoldehyde. 3 carbon atoms are over. Here we are using of 2 is there. It is called as nothing but the eth. It is there. So here also acetic acid. If you are having the 2 carbon atom, means is acetic acid. Already it is the iopactate means ethanoic acid. Ethanoic acid. Like that we are using oic. If it is all called as a carboxylic acid, commonly called as a oic acid. This is particularly aldehyde is called as a all. AL. This is OL. Means methyl alcohol I can call as a methanol. Methanol. See friends, see the pronunciation is same, but the writing the OL here. This is called as ethanol. Here, this is the 2 carbon atoms are there. It is nothing but you can call as ethanol. See, AL. Don't think about ethanol means it is not an alcohol. AL is present means aldehyde group. Oic acid, ethanoic acid. It is also called as ethanoic acid. So in the multiple choice question, they are confusing to you. They are writing the formula out. If you see that one, which is the functional group is there, is the CHO functional group is there. It is called as AL. We are using of this particularly. AL is the functional group. OL is the functional group is called as alcohol. Oic acid is the functional group is called as your acid. Okay. So if you are having of this is called as a ketone. C double one O. It is called as a ketone. Writing down general formula, that is the C double bond O CH3. This is called as acetone. This is called as one. One is the common name. One is the common name. Okay, one. Acetone. O-N-E. One. Not one. It is pronouncing is one. Acetone. So these are very important functional groups. OH is called as alcohol. CHO is called as aldehyde. COOH is called as acid, and C double bond O is called as a ketone. Aldehyde, ketone, carboxylic acid, and alcohols. Some it is important you are having of this functional group which are generally used in our organic compounds. Okay. Now we have specified some more example. Why? Because the classification of organic compound based on the functional group, I given 3 plus 4, 7 over. Minimum you have to write 10. I will explain the remaining other also because it is 10 marks question. So remaining are just practice is only. This is the only the thing is practice. If is a NO2 is present, this is called as nitro. The functional group is called as a nitro. I'm using same CH3NO2. This is called as a nitro. Methyl nitrate or nitromethane. Nitromethane. If it is called as amine, NH2 is called as amine. If you are using of CH3NH2, methyl amine. It is a methyl amine. Okay. If you are having of the CN, this is called as a cyanide. It is a cyanide. So you are writing of CH3CN, methyl cyanide. If you are writing of NC, yes, CN is a cyanide. This is NC is called as isocyanide. This is isocyanide. So you are writing the same CH3NC means methyl isocyanide. Or you heard about this methyl isocyanide anyway? Our India in the Bhopal tragedy in 1983, December 22nd, midnight, the methyl isocyanide is evolved in the Bhopal city. Almost all 20,000 people are died on the spot. This is the isocyanide, very dangerous, very poisonous. The gas is very poisonous. The symbol is NC, methyl isocyanide. This gas is only mixed. It is called as a mixed gas. Methyl isocyanide, MIC. It is also pronounced as a MIC, mixed gas. This is the biggest tragedy in our India in the 1983, December 22nd midnight. In the Bhopal city, that is a boiling, that is a tube is blasted. Then that methyl isocyanide is exposed into the atmosphere. In the spot, only 20,000 people have died. So this is about the methyl isocyanide. And one more is you can CONH2, amide. Amide group, CONH2 is the amide group. So I'm writing the general formula of amide is already you are familiar with that. Amide is CONH2NH2. This is called as a urea. First organic compound which is prepared in the laboratory. That is a urea. This is the amide one. Okay. So friends, like so many are there functional groups, but particularly regularly you are using of this particular compounds. That is these are the nitro, amino. This is the amine group, primary amine. This is the and cyanide, isocyanide, amide. Okay. So like that, ether also ROR means R is the alkyl group, and also that is also a group. This is a O only. This is called as the ether. Simple O. That means if we are writing of R, that means C carbon present in between, that is called as a ether only. You can using of any ethers. Acetone is like that. The keto bond is there. So like that, you have to remember in the examination point of view. This is enough for your classification of based on the functional group. Please practice it. It is also asking your examination for 10 marks question. Okay. So friends, next we will go to the next another topic. Before starting of the topic, just I will supposed to clarify the what is the main important. The 4 covalent bonds are present in our carbon compound. Why it is formation of the 4 covalent bond? You know that already carbon is the 6th element in the periodic table. We are writing the electronic configuration when suppose this carbon is in the ground state. Whether the carbon is in the ground state, we are writing this is the 2s2, writing of the expanding nature of 2pxy, 2py1 and 2pz0. This is a clear, that means correct electronic configuration of the carbon. 1s2, 2s2, 2px1, 2py1, 2pz0. That means in this last shell, this is the last shell. In this consisting of off-filled orbitals, px and py is having of the 2 lone pair of electrons are there. If the compound is having of the lone pair of electrons, how many number is there? 2 is there. So it can form 2 covalent bonds. It can form 2 covalent bonds only. But if we see previously whatever we have studied the carbon compounds, all carbon atom in any organic compound, carbon is a tetravalency. How it is possible? You are seeing of this is only 2 covalent bonds are there, but you are saying of tetravalency, 4 covalent bonds are there. So in this case, what happened? The carbon in the excited state. In the excited state means you are giving them some energy. In the excited state, what happened? This electronic configuration is modified. The s orbital where 2 electrons are jumped into the p orbital, that is 2px1, 2py1, 2pz1. If you see, observe this one, your last shell means second shell consisting of 4 off-filled orbital. Unpaired electrons are there. 4 unpaired electrons. Due to the 4 unpaired electrons, now this particular carbon forms 4 covalent bonds. 4 covalent bonds are present. Okay, carbon can forming of 4 covalent bonds, right? Why? Because it is the excited. You are giving some amount of energy to the carbon atom. It is excited, so that the electron is jumped in the z orbital. You are getting of the 4 covalent bonds. Fine. But if you see the methane molecule means carbon and hydrogen. 4 carbon atoms are there. 4 carbon means one carbon atom, 4 hydrogen atoms are there. The carbon atom general electronic configuration is 2s1, 2px1, 2py1, 2pz1. And hydrogen, 4 hydrogens are there. Each hydrogen is, the electronic configuration is 1s1. Right, friends? Here 1s1 is there. Here we are adding on the 4. 1 electron is belongs to the carbon atom s orbital. 3 electrons are belongs to the p orbital. In this p3 orbitals, now we are using of the carbon atoms in the methane molecule. This particularly 1 electron is belongs to the s orbital. S orbital is, what is the shape of the s orbital? It is a spherical shape. P orbital shape is the dumbbell shape, which are present in the px axis. That means x direction 1 electron is there, on the y direction 1 electron is there, and z direction 1 electron is there. But in the methane molecule, carbon can forming of all equivalent bonds are present in the methane molecule. All equivalent bonds, and this bond length between the carbon and carbon, it is 1.09 angstrom only. Any carbon bond length, carbon hydrogen bond length. Any carbon hydrogen bond length is 1.09 angstrom. How it is possible? The question is why? Because the carbon is having of the 4 off-filled orbital. That means unshared orbital is not shared electrons are there. But in this, 1 electron is belongs to the s orbital. S orbital is spherical one. 3 belongs to the dumbbell orbital. That means p orbital. That is the dumbbell one. The properties, whatever the physical and chemical properties are differ by this one. But if we are showing up in the methane molecule, carbon is showing all equivalent bonds only. That is a 1.09 angstroms only present in the carbon and hydrogen. How it is possible? So scientists are thinking that why happened it is when you are formation of the methane molecule, in the methane molecule carbon hydrogen bond is 1.09 is showing all 4 bonds are equivalent only. But it is belongs to the 1 electron is belongs to the s orbital, 3 electrons are belongs to the p orbitals. How it is possible means they introduced one concept, that is a nothing but the concept is hybridization theory. What do you mean by the hybridization? If you know that one in generally, If you are familiar with your rose, normal roses are there, hybrid roses are there. How it is there? You can easily differentiate normal roses and hybrid roses. The thing is hybridization. Why it is happened means hybridization is what? In this organic chemistry, Linus Pauling is proposed in that particularly inorganic part actually. Now we are introducing in this particular also because of the methane molecule is showing up all 4 covalent bonds are equal in size. Equal in size means we are getting of the some concept is there that is called as a hybridization. Now the hybridization is nothing but mixing of, please listen the definition of the hybridization. Mixing of pure orbitals of same atom of similar energies. So these are the words we are saying. What is all? Mixing means you are mixing. What you are mixing? Same atom means you are taking only one atom, not other atoms. In that same atom, similar energy. Energy also very important. I am mixing of second orbit, second energy, not the first orbit energy. This same energy, these are the mixing of pure orbitals, s orbital, p orbitals of second energy, that is a second shell energy. Mixing of pure orbitals of same atom of similar energy. I'm mixing carbon atoms. Okay, same atom. Similar energy means second orbit only. That energy is orbitals. Which orbitals? S orbital and 3 p orbitals we are mixing. We are getting a same number of how many I am mixing now? 1 belongs to the s orbital, 3 belongs to the p orbital. Total I am mixing the pure orbitals 4. Mixing of pure orbitals of same atom of similar energies. I am mixing the same atoms, similar energy atoms, similar energy orbital. Those are, one is s, remaining are 3 p orbital. Mixing to get same number means 4. Same number 4. We are getting the 4 new orbitals. 4 new orbitals are formed. This phenomenon is called as hybridization. Now I can write the hybridization. What do you mean by the hybridization means? Mixing up of pure orbitals of same atom of similar energies. Similar energies to form same number of or equal number of, otherwise you can get equal number of new equivalent new orbitals is called hybridization. Nothing, Amma. I can use the one simple example. Morning, are you prepared for the dosa? For the dosa, how can you eat? With the chutney. How can you prepare the chutney? You are taking the pallis, you are taking the coconuts, okay? You are taking some other ingredients. These are mixing in the grinder, right? Understand the point. Hybridization. I'm taking the pallis, coconuts, and other ingredients. I'm taking into the mixer. You are grinding. After the grinding, you are getting up. Your name is what? That is a chutney to eat the dosa or idli. See, friends, here in the mixing of the whatever the ingredients, you are getting the new product. The new product is called as your chutney. Here also, mixing of the similar energies atom, same atom of similar energies, you are getting of the new equivalent orbital, that is called as hybridization. In this carbon atom, 1 s orbital and 3 p orbital mixing each other, formation of 4 sp3 hybrid orbitals is called as sp3 hybridization. That is nothing but what are the hybridizations are there? So far the hybrids are sp3, sp2 and sp hybridizations. Your examination point of view, these are the 3 are important. Again the 5 mark 10 marks question. See friends, in this first chapter only, so many number of 10 marks questions are there. Classification of organic compound, classification of functional group. Next is the hybridization. Okay, next so many are there still. Okay, first is the hybridization. Is you have to understand the concept of the hybridization. Then you will go to the what is Sp3 hybridization, what is Sp2 hybridization, what is Sp. So simply ask, define Sp3, Sp2, Sp hybridization and explain with the examples. That is a question in our 10 marks question. So first we have to define what do you mean by the Sp3, what do you mean by the Sp2. Let us see that one. We'll discuss that one. First, Sp3 hybridization. So friends, already we are familiar with the excited state electronic configuration. Write the electronic configuration 1s2, 2s1, 2px1, 2py1 and 2pz1. In this, I am defining the Sp3 hybridization. Please carefully listen. Sp3 hybridization means one spherical shaped s orbital, and three dumbbell shaped p orbital mixing each other, formation of 4 Sp3 hybrid orbitals. Formation of 4 Sp3 hybrid orbitals is called as Sp3 hybridization. Means I'm taking off. This is 2s1. Next, I'm taking off. Please think this is the dumbbell shaped p orbital. It is a px, it is a pz, it is a py. Okay, the clear about these are the dumbbell shaped. This is the exactly link this one. Now one s orbital, three dumbbell shaped p orbital mixing each other. Formation of 4 Sp3 hybrid orbitals. 4. We are using of this one particularly. I am writing of the Sp3 hybrid orbitals. See friends, here the 4 Sp3 hybrid orbitals are formed. These 4 Sp3 hybrid orbitals are called as Sp3, 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 Sp3. 4 Sp3 hybrid orbitals are present. It is called as Sp3 hybridization. Each Sp3 hybrid orbital, these 4 Sp3 hybrid orbitals are arranged on the carbon atom. Arranged will be tetrahedral structure. This structure is tetrahedral. Tetrahedral structure. And the making of the bond angle is the bond angle. This bond angle between the Sp3 bond angle is 109 degrees 28 minutes. Please remember this one. 109 degrees 28 minutes. That means on the carbon atom, the Sp3 hybrid orbitals are arranged in the manner of tetrahedral structure, and the tetrahedral structure bond angle is 109 degrees 28 minutes. These 4 Sp3 hybrid orbitals means now again I am writing off one time more. This is the okay. This 4 Sp3, writing off this one. In the methane molecule, 4 hydrogens are there. Each hydrogen is 1s1 again. So just I am adding off 4 hydrogens. 4 hydrogen means each one is a spherical shape. This is the one spherical shape. 1s. These are the 2s and 2p. These are the 2px, 2py like that. This is belongs to the 4 hydrogen atoms. 4 are present. 4 hydrogen atoms. This is the H. Okay. These 4 hydrogen atoms are bonding. Now we are mixing. Mixing of that one, you are getting off carbon atom. Now this is a one hydrogen, another hydrogen, another hydrogen, another hydrogen. Okay, there is a formation of these are the hydrogen. This is hydrogen. This is hydrogen. This is hydrogen. It is hydrogen. It is sp3 hybrid orbital. It is not pure orbital. It is hybrid one. It is hybrid one. Okay. Now here there is a linear overlapping takes place between the sp3 and H. There is a linear overlapping of sp3 and H. There is a linear overlapping of sp3H. There is a linear overlapping sp3H. When the linear overlapping, that means this overlapping takes place, a bond is formed. This bond is called as a sigma bond. Here a sigma bond is present. 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 In methane, how many sigma bonds are present? 4 sigma bonds are present. This is a sigma. The symbol is like that. 4 sigma bonds are present. This is about the methane molecule, which is the example of your methane is the example of sp3 hybridization. Methane is the example for sp3 hybridization. So friends, please remember what is first you define that what is the sp3 hybridization. Means simple. The words are one spherical shaped s orbital, 3 dumbbell shaped p orbital mixing each other to form 4 sp3 hybrid orbital is called as sp3 hybridization. Each sp3 hybrid orbital, that means all sp3 hybrid orbitals are arranged in the tetrahedron manner and making of the bond angle is 109 degrees 28 minutes. In the methane molecule, these 4 sp3 hybrid orbitals are again mixed with the 4 hydrogen atom. Formation of this is the methane molecule structure. This methane molecule structure, we are having of the bond angle is 109 degrees 28 minutes. And making of the how many sigma bonds are making? 4 sigma bonds. Why? Because it is a linear overlapping takes place with the sp3H. sp3H. About this is about the example of sp3 hybridization. Okay, friends. Now we will go to the sp2. How it is simple. We see. Once you got the concept clearly, you can easily write the sp2, sp also. First, remember what do you mean by the sp3? You have remember that one spherical shape, 3 dumbbell shape. 1 plus 3, total how many you get? 4. 4 sp3s coming. New equivalent orbitals, same number of new equivalent orbitals will come after the hybridization. Okay, so same number means how many pallis, how many coconut you are added, that much is present in the chettina, does not go anywhere now. So here also we are mixing how many number that will be present in this case here also. This is about the sp3 hybridization. The example is methane molecule. This is called as a methane molecule. Now coming to the sp2 hybridization. In this sp2 hybridization, what do you example? Define it. sp2 hybridization means sp2 hybridization means one spherical shaped s orbital, 2 dumbbell shaped orbital. 2 dumbbell shaped, what are those? Only I am taking up px and py. This is a px, this is a py I am taking. This is a px, this is a py. One spherical shaped s orbital, 2 dumbbell shaped p orbital to mix each other to form how many number? 1 plus 2, 3. Those 3 are 3 number sp2 hybrid orbitals are present. 3 sp2 hybrid orbitals are present. These 3 sp2 hybrid orbitals are called as 3 sp2 are arranged in the angular, triangular, pyramidal shape or triangular shape, making of the bond angle is 120 degrees. Making of the bond angle is 120. See the triangular shape. This is the I am using of the triangular one. Okay. For this is called as a sp2 hybridization. It means one spherical shaped s orbital. That is a 2s. This is a 2p. 2 dumbbell shaped p orbital. That is a 2px, 2py. Formation of 3 sp2 hybrid orbital. These 3 sp2 hybrid orbitals are arranged in a triangular manner, triangular shape, and making of the bond angle is 120 degrees. Is called as sp2 hybridization. Example is your ethylene molecule. Ethylene means C2H4. Ethylene molecule. Symbol of the, that means here there is a structure will be writing of CH2 double bond CH2. CH2 double bond CH2. How? And means each carbon is 3 sp2 orbitals are there. Here 3 sp2 orbitals. See friends, this is 3 sp2. Okay. And each case you are adding up the, this is sp2, this is sp2, this is sp2. Again you are adding up one more carbon atom. There is a double bond is present. So the carbon atom between the carbon atom, here sp2 is there, sp2 is there. This is the sp2, this is the sp2. Okay, it is also sp2. There is a overlapping takes place. How the overlapping takes place? I will write in the one form. That is nothing but, this is the carbon atom. Okay, one sp2, another sp2, another sp2. For my convenience side, I am using of this one. This is a sp2, this is a sp2, this is a sp2. Okay friends, this is sp2. I am written as next carbon atom side by, it is there in the carbon atom, this sp2. This is also sp2 of this carbon atom. It is sp2, it is sp2. See friends, here these are present of this one. In that sp2 there is a carbon between the carbon, there is a linear overlapping takes place. These are linear overlapping take place, but each carbon atom is adding of 2 hydrogen atoms. The 2 hydrogen atoms, here 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 the 2 hydrogen atoms. It also lateral overlapping takes place. This is the lateral overlapping. Okay, here lateral overlapping also takes place. In this lateral overlapping, see how many? This is a sigma bond, sigma bond, sigma bond, sigma bond, sigma bond. Total 5 sigma bonds are over in the formation of ethylene molecule. But in this case, what happened? There is a these two are mixing in the hybridization. One s orbital, two dumbbell shaped orbital, but pure p orbital still there on the carbon atom. Pure pz orbital. Pure pz orbital. This is the pure pz. This is the pure pz. This pure pz orbital is there. So this pure pz orbital, lateral overlapping takes place. This is the lateral overlapping. It is called as a lateral overlapping takes place. Is lateral overlapping formation of pi bond.
Silent lo pettu.
Overlapping, due to the lateral overlapping, pi bond is formed. This is called as a ethylene molecule. So in the ethylene molecule, you are having of the 5 sigma bonds. 5 sigma bonds are there. So sigma bonds are formation of linear overlapping. One pi bond is present. One pi bond. This is a pi bond. Due to the formation of a double bond. This is a your indication of the here a sigma bond. One is a sigma, another a pi bond is there. And anyhow, 2 hydrogen, 2 hydrogen, 4 sigma bonds are there. Total 5 sigma bond, 1 pi bond is present in the ethylene molecule. Please clarify this particular about the sp2 hybridization. sp2 hybridization means one spherical shaped s orbital, 2 dumbbell shaped p orbital mixing each other. Formation of that one, they are getting up 3 sp2 hybrid orbitals are formed. These 3 sp2 orbitals are arranged in a trigonal planar, taking out the bond angle is 120. The best example is ethylene molecule. In this ethylene molecule, there is a double bond is present. That is double bond is nothing but the pi bond is formed between the lateral overlapping of pure pz orbital. Lateral overlapping of pure pz orbital, you are getting of the 5 bond is present. Little bit 2 more minutes. I will take the sp hybridization also. I will finish that one. What is the sp hybridization? So sp hybridization means one spherical shaped s orbital and one dumbbell shaped p orbital. This is I am taking out px. I am not taking any one, only 2 px I am taking. So formation of two sp hybrid orbitals on the carbon atom. On the carbon atom, 2 sp hybrid orbitals. These 2 sp hybrid orbitals are arranged in the linear structure. The linear structure is there, and the making of the bond angle is 180 degrees. Making of the bond angle is 180 degrees. Very simple one. One s orbital, one p orbital, dumbbell shaped p orbital, mixing each other. Formation of 2 sp hybrid orbital is called as sp hybridization. These sp hybrid orbitals are arranged on the carbon atom in the linear form. So making of the bond angle is 180 degrees. Now the example is ethylene molecule. Ethylene, that is nothing but you are having a C2H2. That is nothing but you are having the structure is a triple bond is present between the carbon and carbon. This is the structure. See the carbon, each carbon is the 2 sp is there, and in the 2 carbon atoms here. Okay, so these are lateral overlapping takes place. Here sigma bond is present. This is sp, it is sp, it is sp, it is sp. But 2 hydrogen atoms are present. 2 hydrogen atoms. 2 hydrogen atoms. There is a lateral overlapping. Means total we are getting of 3 sigma bonds. But in this case, only pure, that is a px orbital is involved in the hybridization. Remaining 2 py pz are still present on the carbon atom. Those are pure py pz orbitals are present on the each carbon atom. This is py. This is pz. So friend, observe on each carbon atom like this only. This is a px. This is a pz. So pure two p orbitals are present on each carbon atom. Those pure p orbitals are lateral overlap will take place. This is called as a lateral overlapping. I'm using the red color. This is the lateral overlapping between the pz, between the pa, py, you are using of that one. You are getting of the lateral overlapping takes place. Means how many lateral overlapping takes place? 2. 2 means 2 pi bonds are present. Okay, this is a hydrogen, this is a hydrogen, and making of the bond angle is 180 degrees. It is a linear structure. It is a ethylene molecule. In the ethylene molecule, 3 sigma bonds are present. Because of the 3 sigma bonds, in this belongs to 2 sp-sp. That means 1 sigma bond is present between the sp-sp. Another sigma bond between the sp and h. Another sigma bond sp-h. 2 pi bonds are py, lateral overlapping. This is called as a lateral overlapping. Okay, this is called as a linear overlapping. This is a sigma bond. It is called as a lateral overlapping pi bond. Pi bond is a weaker bond than the sigma bond. Why? Because the electron density is distributed above and below the plane. But in the lateral overlapping, the electron density is present here only. The center, the electron density is there. It is a strong bond. You can't remove. But lateral overlapping easily remove this one. That's why the pi bond is a weaker bond than the sigma bond. Remember. So in this case, we are adding up the hybridization in the particularly ethylene molecule. We are adding up the 3 sigma bonds and 2 pi bonds are present. Okay, friends. So this is about the hybridization. So anyway, this hybridization and the functional groups and also your classification compulsory questions in the examination point of view. Mostly this is a very, very important hybridization. Compulsory question. We have to write the 3 hybridization: sp3, sp2, sp. First write the what do you mean by hybridization, and next you have to classify. That means sp3 means 1 spherical shaped s orbital, 3 dumbbell shaped p orbital mixing each other. Formation of 4 sp3 hybrid orbital is called as sp3 hybridization. These 4 sp3 hybrid orbitals are arranged in the tetrahedral manner, and making of the bond angle is 109 degrees 28 minutes. Example is methane or ethane, whatever the you can have the both examples in the sp3. Next, sp2 means 1 spherical shaped s orbital, 2 dumbbell shaped p orbital mixing each other to form 3 sp2 hybrid orbitals are formed. This phenomenon is called as sp2 hybridization. These 3 sp2 hybrid orbitals are arranged in the trigonal planar structure. Making of the bond angle is 120 degrees. Example is ethylene molecule. Ethylene molecule means ethene. It is generally called as a ethylene molecule. Next, sp hybridization. One spherical shaped s orbital, one dumbbell shaped p orbital mixing each other, formation of two sp hybrid orbital is called as sp hybridization. These two sp hybrid orbitals are arranged in the linear structure, making of the bond angle is 180 degrees. Example is ethylene molecule. In the ethylene molecule, we are having of the triple bond is there. Why triple bond means one bond is belongs to the sigma, remaining two bonds belongs to the pi bonds only. These two pi bonds are very weak. Already told that why sigma bond is stronger than pi bond. If they ask the question means the sigma bond is formation will be on lateral overlapping. Due to lateral overlapping, this is a head on head overlapping or end on end overlapping. This lateral overlapping means it indicates as the electron density is concentrated here only on one place. You can't remove that one. So it is a strong bond. Lateral overlapping means this is a lateral overlapping. There is a horizontal axis is there. There is an axis is linear axis is there. Above and below the plane, the electron cloud is present. So cloud is dispersed, distributed above and below. So this much of not strong on lateral. This is particularly linear. So that's why lateral overlapping, the electron cloud is distributed so that the particularly you can easily remove this lateral overlapping. That's why the pi bond is weaker than the sigma bond. So friends, this is about the hybridization. Next we'll learn about the isomerism is there. Particularly not only isomerism, because that one we are using of the nomenclature. IUPAC nomenclature, how to write the name of the organic compound. What are the rules are established by the IUPAC system, Indian Union of Pure and Applied Chemistry. Those systems, that is a one society is there. The society given as some rules. According to the rules only, you can frame the name of the any organic compound. Suppose if you prepared in the laboratory, so naming means you have to use the conditions will be followed. Whatever the rules are given by the IUPAC system, you have to follow. Then only you can name it as that one. So you can go to that one. Tomorrow we'll see about the isomerism and also IUPAC nomenclature. Okay, friends, any doubts? So,
No doubt, sir.
today is the topic. Just go through the today topics. Why? Because it is a fundamentals, very important fundamentals of the organic chemistry. If you learn, if you are perfect in the fundamentals, next topics will be very easy to you. Okay, so